Hello again from Limassol, Cyprus, from the European Nano Safety Cluster NanoWeek and NanoCommons Final Conference. We are now here in our final training session, session 5, on integrating nano-related data by linking instant maps or using instant maps to electronic data management systems. And we are also going to look into standard operating procedures integration into such kind of workflows. This session was done by Jalicia Amos from the Duke University and Benjamin Puntz and Letty Johnson and myself, Martin Himley from the University of Salzburg, as well as Katie Raleigh from the University of Birmingham, and online joining Thomas Exner, 9:07 in Germany.
Training session on instant map tool and how this interconnects protocols, organizes experiments eventually, but also other things, and connects to data. And we would like to start with this. We have a number of presenters today. First of all, we would also like to welcome Thomas Exner, who is joining from Germany, from 9:07, who is here. Thomas, you hear us?
Yes, I do. Hello.
Okay, this is Thomas. He will be also jump in several times probably, and we will ask him a couple of times. Then we have here Jalicia Amos from the Duke University, where probably all this work started off, and she will give us at very first now kind of an overview on the history, how this story evolved. We're also having with us Katie Raleigh from the University of Birmingham. We do have Ben Puntz and Letty Johnson and myself from the University of Salzburg. And with this group of people, we are now working a little bit into this instant map, what this is and what this could be, helping you in experimental workflows primarily. But actually, it's also possible to use it for regulatory aspects, as Thomas is then maybe also a little bit alluding to. Good. Jalicia, would you come close to this microphone, please?
Hi, everyone. My name is Jalicia, and I am going to give you all a brief history of instant maps and how they started and how they have evolved. So I guess actually to start, when I joined the Wisner Lab, my assignment as a postmaster's position was to curate data into the NIC database. And so for anyone who doesn't know, this is the internal structure of the NIC database. And so what this structure allows us to do is it allows us to track the transformations of nanomaterials over time. When I was assigned to this goal, at the time there was no workflow in progress, and so I was curating this work from literature, and so I was trying to identify what instances are, and then trying to organize that in such a way that I can curate it into the NIC database. So this was actually my very first instance map. It's a mess, and I don't really think you can really make sense of it. And that's because I was developing this process as I was going. And so I think now it makes a lot of sense to just find those transformations that are occurring in the literature and then just turn it into a map. But when I was starting out and there wasn't a process involved, this was kind of how I put this process together. So just to give you an example of what this looks like curating from literature, this was from a study that I curated into the NIC database. And so essentially what they did in this study is they took nanomaterials, dispersed it into a solution, and then exposed it to a living organism, and then looked at the bioaccumulation of that. So when trying to organize this into an instance map, which will allow us to look at those transformations over time, the first thing was to identify how many instances were occurring and what those instances were. So I know that this is difficult to read, but I will walk you through it. So the first instance was the characterization of that nanomaterial. And so in this paper, they were looking at a silver nanomaterial, and they characterized the shape of it, the physical state of it in terms of whether or not it was in a liquid state, and then its purity. And the second transformation that occurred was that they then suspended that into saline. And then they looked at the new characteristics of that nanomaterial in this new media. And then finally, they did the exposure, and they have the characteristics of the mice themselves. And then they then tracked where were these nanomaterials going. And so not only were they looking at where are these nanomaterials going, but they were also looking at what damage were these nanomaterials causing along the way. And so this is an example of how you return that paper where those instances are not defined, because this is a NIC defined definition, into that instance map where we can then, in a systematic way, look at those transformations as they occur over time. So that was a short instance map, but I think the power of these instance maps is that it allows us to capture a lot of complexity in a way that is easy to communicate. So this is another instance map of what was curated from another paper. And you can see through all these blue boxes, all of the transformations that have occurred over time, which can allow us to interrogate that data a little bit better. And so just to walk you through, this first part of the instance map here is when they took the nanomaterial and then functionalized it. And then what they did was they exposed it to an organism at different doses, which is what each of these lines are. And then they looked at how those different doses to that organism change the reactivity over time. And so I think what's easy to see at this point is how we can use these instance maps for other purposes. One of those new purposes is the nano-inchi, which we've heard a lot about. And so what we have done is we've used the same instance map, but instead to look at the synthesis of that nanomaterial. And then looking at this instance map and the synthesis of the nanomaterial, this can help us to create a naming system for those nanomaterials. So this is kind of a brief overview of where this instance maps has come from. And I will turn it over so that we can see how these instance maps have evolved. And I think on a personal note, I think what's really interesting for any scientist, the goal is always to create something useful. And not only to create something useful, but something that can be used beyond its intended purpose. And I think with the work that has been done at NanoCommons and with Thomas Exner, they have helped to breathe new life into instance maps and also to find ways to apply it in new ways that I never could have imagined that it could be applied looking forward. And so it's very cool to see that we have gone from this mess to a tool that has been created that can be accessed by all of you to create your instance maps, your SOPs, your protocols that can then be used to communicate with other people who may not be familiar with your work. However, but with these instance maps, which helps to break down these transformations, you can more easily communicate with someone who maybe doesn't have the same background as you. So I will now turn this over so that we can see how this work has evolved.
Great. So we have now Ben here, who will, together with us all, generate in this tool that was mentioned an instance map based on a study that has been performed. So what we do, we just drag from literature, unless you have a concrete suggestion. We would then just grab something from literature which we have worked with. Jalicia was mentioning synthesis, so why don't we start with the synthesis of a material and then characterize the material and then look into some biological endpoints. And this is a kind of a complex experimental workflow. And this is what probably many people in this field have done or have been doing in certain different colors and flavors. So why don't we start drawing such a map?
Good. Then also welcome from my side. I'm currently on the tool itself, provided by Thomas Exner in 7+9. I also have to mention...
Sorry, quite
Yes.
quickly. I'm not sure if you did that already, but if somebody wants to access, please send me an email and I can give you access immediately. I'm not sure if you said that already, but just to that everyone knows that. Sorry about interruption.
Oh, good. Feel free to interrupt anytime. So now, basically, here on the website, you can now see all the instance maps that have already been created by all kinds of different people. But for example, we can now create a new one with, with a paper, for example. So first off, you have to name your instance map. I'm just going to name it like it has the same name as the paper. Then you can set it if only you can see it or if everybody in the instance map group can see it. So now you basically see an empty sheet, and then you see a lot of different colored instances or boxes that you can just drag and drop here, and you can name them. So we can now look into the paper, how we're gonna build this. This is just gonna be a rough showcase because we already built this instance map and also built it quite in an extensive way. So this is just a basic rough draft, and later I can show you how this would look if you really go into detail and add more and more instances. But as Martin said, let's start with the synthesis of nanoparticles. Let's call this, for example, here. This is instance 1. Yeah. I can't find the double point, but whatever. Instance 1, let's call it synthesis of nanoparticles. And you can add, then you can add some descriptions, for example, if you want more detail. But here you can now see your instance. Then we probably have to add some materials for the synthesis or medium potentially. Here in the paper, I already know this paper, so we can just name this TIAS because the synthesis was performed for silica nanoparticles and the precursor of this is TIAS. And then you can connect those two boxes like this. Then you can see a little arrow that those are connected. In case you don't like it, what you've done, you can always delete the instances with remove node, or you can also delete the arrows, or you can also name the arrows. For example, here we can write synthesis, and then you can see on top of the arrow what you're doing with this material. Then we can continue reading. For example, in this paper, we functionalize the surface of the particles with chemical groups. So we may need additional, for example, here we can use a transformation protocol, because with further chemicals, we add, for example, carboxy surface groups or amino surface groups on the surface. Carboxy functionalization. Yep. Okay. I will just use this one alone now. And then you can also add more materials. For example, we used Meldrum's acid for this, for the functionalization. And then out of this, you get a new instance with functionalized particles. Instance 2, functionalized MPs. So then when you go through the paper or whatever you want to build your instance map with, you can keep on building upon that. Add different protocols. For example, if you measure them, you can add like curated properties or computed properties. But all in all, after some time, something like this will show up when you keep on adding new stuff. For example, here, what we already went through, we have the starting materials, the synthesis with the different methods you can make. For example, silica particles can be created with the Stöber method or with the microemulsion method. And then you have the pristine particles, they can be functionalized. And then we have to characterize the particle, like, for example, see how big they are, or how monodispersed or polydispersed they are. For example, also TEM pictures. Then you keep on adding to that. And then a really big map appears, which basically summarizes the whole paper. And you can look at this with just one gaze.
So considering the situation, you're working at the university or working in a company or something, and you have a new coworker, and you have a designed small project for this person. Like, for example, from my perspective, I would like to take the example of a new master student or PhD student. No, usually we start with, okay, come here, this is the institute, these are the instruments, and so on. And this is your project. Then you actually talk a lot, 2 hours, or maybe 1 hour or something, you explain what the project is about. Then usually you give some background reading to the person and let the person design or somehow try to digest this kind of stuff. And at our university, for example, this will be probably quite similar to other academic places too. At the advent of a PhD thesis, for example, they have to then compile this kind of information into a disposition, which they have to deliver in a talk or in a kind of a piece of written text to somehow display this plan, what they have in front of maybe the department. And then the PI say, well, okay, this is a cool project. This is the idea. Yeah. So basically you plan 3 years of a PhD or 4 years of a PhD thesis in advance. And what have we done so far? There is lots of written text, which you have to read a lot. And then there is maybe a timeline and a couple of tasks or kind of experimental phases of this, what the people are somehow designing. And for example, an idea that we came up with that instead of doing that, what we have done so far, design the project, let the people digest it, and let them, for example, draft such a kind of mind map, instance map, Yeah, what are my instances? What are my tasks? How are they connected? How do they connect, for example, in my rather vertical experimental workflow to maybe some horizontal keeping of cell lines, or keeping of Daphnia, or keeping of or kind of provision of primary cells from the hospital or something like that. So it's a kind of a structure-giving system which aids the understanding of what my experimental workflow is going to be. And if after several rounds of feedback and kind of corrections, probably the student or whoever has then accomplished with the map, that the PI would say, well, I don't find any mistake anymore, then probably you have really established, designed your experimental workflow for even a long time, and then you can even further modify if you think, well, now we are looking into a different functionalization, and in the end you are quite complete with a workflow. And this workflow could then be eventually also shared with others, or kind of learned on the basis of that, or kind of evaluated in a way. So this is the incentive behind it, because I mean at very first glance it may look, why shall I do that, right? But the advantage comes with the integration of other functionalities of this system. Shall we have a quick look? Because now we looked at particle synthesis, we looked at some human systems. Shall we have a quick look at the ecotoxicological workflows? So Katie, I was already talking a little bit about keeping of cell lines or keeping of animals. Maybe we see this in her example.
Yes, thanks. So I'm going to try and find... I'm pretty sure mine are all set to public now. So the way that I approached it was to come at it from looking at adapting the test guidelines, like the OECD ones, into written protocols for the lab, and then into instance maps that then we can link to data capture sheets. So this is the one that I was just... Yeah. I have too many Daphnia ones. I think that's one that Thomas has edited for me, which is super helpful. I want the one from this one, the 5th. There we go. So this is the one that I prepared that looks at the... Oh yeah, thank you. There we go. Hopefully you can just about make out what it says in the boxes. So this is an instant map that I prepared based off of the OECD 202 acute test, with a slight adaptation on the left for nanomaterials and what we need to do in terms of the characterization steps and things like that, before moving over. So the kind of the middle part is where we would start the actual exposures to Daphnia. Then we have like the mortality observations, mortality counts, moving towards the LC50 value calculations. And what I really like about this is it's, I think if I give the test guideline to like a project student, like Martin was saying, it's very overwhelming to have to read through. I think the 202 test is like a 12-page document. And although they have data capture templates, I still don't think it's super accessible. So I think this is a really nice way that you can then say, right, this is the steps that we need to do. On the left, we can link to data capture templates or other SOPs that we'd need in terms of the characterization steps to do with like the nanomaterials or particles we're working with. And then on the right, with the mortality counts, we can then link to other data capture templates specifically to do with the kind of mortality that would be observed in the lab. So I think that's really useful. One of the features that I'm really looking forward to is being able to link different instance maps together that I was talking to Thomas about a couple of weeks ago. So I think at the bottom, it probably really isn't that clear, but it just says running culture observations here. So I think it's really important to have like baseline observations of culture health over time. And I'll see if I can find I thought, and this is such a learning curve, that it'd be really easy to visualize how you culture Daphnia, because it's something that you do day in, day out. And when I did the culture map, it was actually the hardest map that I did, because I was trying to think how you would then visualize what you do in terms of like cascading cultures. So in our lab, we will keep broods. So we'll take from the 3rd brood to set up our new running cultures, and we'll test from the 3rd brood through to the 6th inclusively. And trying to visualize that or explain it to people that hadn't worked with Daphnia, I found incredibly challenging. So that was a really nice learning curve. And Thomas was super helpful in terms of how you can structure stuff and what is important to include in the map and what you can include in data capture templates. So that was really, really helpful. So at the top, we've got just about medium preparation and the algae culturing and preparation. And some measurements here in terms of like dissolved oxygen, total hardness, and pH, which are really important observations when we go on to the testing steps. And then this just shows how you can use the maps to then just cascade across. So for example, if we had particular issues with one of the cultures, for example, so I work in various media. So if we found that one of the medium crashed, we could then look back and see, well, was there like a dip in the dissolved oxygen, or could there be some other issues that's affecting that one in particular? So I think that's quite a good way to do some like quality control in the background. There was one other point that I wanted to make, and I can't remember what it was. It might have been about the chronics.
Maybe a question in between.
Yeah.
What do these colors mean? You might want to know, right?
So this one is the chronic one. And I can talk through the colors quickly here. So the kind of the lighter blue colors are bits where an instance is almost happening. So this is an unfinished map, and I was going to like talk through a little bit more. So this one here is the release of the first brood. So in terms of the chronic test, this is one of the first instances that we'd have, and it's important to capture data here. So if we click on it, you can open up the node properties. It gives you the type of node, the name of it, and then it gives you a description as well. So this is how you can then like make these available online, and then other people can read them. I don't think. Can I edit on yours? Okay. Like if I open my map, I can then edit it, right? Or not?
Just make quickly if you want to use mine, just copy it, and then you can do whatever you want.
Oh, okay. Okay. Yeah.
And as we just experienced, we can share such type of our instances, Thomas's, Katie's, Ben's, and you can make a copy, and you can work on that. You can retrieve already work and brain that has already gone into such kind of organizational structure.
There we go. That's loads better. Thanks, Thomas. So yeah, now you can see the different instances that we have on the right-hand side with the different color schemes. So for example, if we click on the release of the first brood one, we can edit quite a lot here. So we can change the type of node that we have, if it's down to like raw data, process data. So this is release the first brood. Then we can switch to the data tab. So if we have data here, we can add it and put a data file. So for example, if you have like a Google Doc sheet, you can put the link here, which is really helpful if you've got like ongoing culturing data. Yeah.
So the question was whether there can be just a link deposited there. We will come to this again and show what else you can put there. But you can put a link to anything which is deposited somewhere.
If you have it somewhere, so for example, I think if you had it in like GitHub, for example, you could then like link to that, but it has to be somewhere that you can access. Like it can't be saved.
It's not a repository. It's just the organization, and it guides you to a repository. So you deposit it somewhere, and you put there the link. But we will come to a couple of ideas where you can put it. It could be, for example, as a Nodo thing. It could be a Google Doc. It could be somewhere in another data storage opportunity. No,
that's a really good question.
Any interruption. Yeah.
Yeah. Has anyone else got any other questions? I've kind of gone through the Daphnia stuff without doing too much Daphnia. No? Everyone happy? Cool, thanks. That was really helpful. Is there anything else you wanted me to go through? Or Thomas, is there anything that I've missed?
I can do something later, but just go ahead first.
Because then maybe at next it's a good idea that Ben again shows exactly maybe then connecting to this question that we just had, we heard about protocols. We heard about 12 pages of protocol. So we are now looking at this organizational structure and what can we link this to.
Okay.
So to protocols and eventually to data.
Martin, then I jump in quickly because just to make the connection back to the original idea. Yeah, you might see that we changed or we added a couple of additional things. The one is that you can link two protocols, which will become much more important because of what Ben will then present. We added different types of properties and we added data nodes. All these things. The big issue with that, or no, not the big issue, the issue we have at the moment is that to do that, we destroyed more or less any kind of rules for building these instance maps. The original what was presented had a very, very defined set of rules, which was very, very good for this application. I think it was the excellent plan to do so, and it also helped us structure the idea around that. But we are now in a stage where we really try to find these different things, and it's not me. When somebody said that this became something out of her was going beyond their imagination, then I have to say that is much beyond my imagination as well, because it's a team building type. But for that, we have no rules in there. You can combine everything with everything, and therefore these kind of full things comes up. But it also offers you the idea to do whatever you want. Yeah, and now hopefully back to Ben, where he can then see that in principle there are two, or one of the major thing I see, and Tassos asked me to put out that there is a lot of data management knowledge behind that. To build these instance maps, I think it's actually the opposite way around, that the data management will come in these. Yeah, you have something in mind, you organize your experiment, and then the data management should also follow that. But then you get a feedback loop from people like Tassos and me, from the data managers, which will then say yes, but not like that. Yeah, but it really happens very, very rarely that this happens. Yeah, but just to let you know that there are some things coming on or are now integrated into that, because we wanted to have exactly what this question from the auditorium was also: how do you now link to data, and what does that really mean, and is there a repository behind that? At the moment we don't know, yeah, but in principle the idea is exactly going in that direction. Yeah, that might be the central piece where then everything is linked out, and at the end you export all that and you have a fair data set. Sorry for interruption again, but please, Ben, go ahead. Sorry.
Good. As Katie already showed, there's a feature called data here. And if you link data, you will see symbols on your instance map looking like this. So for example, here we linked another instance map. If I open this now, you may see that, that we went from a very simple node like this RBL node here, which is red basophil leukemia assay, that we often use in our lab, to a very detailed version of this, like breaking down the protocol, the SOP, into every single step possible. And Thomas was so kind to provide this map and make this map. So you can see that those little nodes that you have can get really complicated. And as you can also see that there's a lot of data attached to it. For example, we explored a little bit working with Google Docs, where we uploaded our SOP to that, where you can see, for example, here, this would be our SOP, and you can individually link certain parts of it. So if people are interested in how you did it, what you used, you could use that, for example. Or an alternate version would be, for example, Synode, which is a electronic lab notebook. And there you can, for example, upload all your SOPs, edit them, also upload your inventories that are available in the lab, like for example, cell models, what you need for the assay. Here we would have the RBL cells and the HE8 cells, and you can add all the necessary details so people looking at the instance map can always see and be informed how to also perform this assay. What's also important to note is, for example, if you use Synode, you can decide who can see those SOPs and materials that you're using by inviting people to your team. So, for example, you can invite all people that you're working with or who are part of your lab, but you can, whoever is not invited cannot access this information.
Maybe also we say quickly how to get access to this Synode.
Yeah, and Synode, this is also this is a individual version provided by 7past9, and you can enter this to this website, synode.7past9.com, and you can sign up there and make a team for yourself and work there. So this is available and kindly provided by Thomas and his company.
Yeah, just very quickly to that, to not make too big promises. This version is a free and fully functional version. Yeah, therefore you can do in principle whatever we do you do, but it's meant to be a training and testing instance. Yeah, therefore it's not secured at all. It has a relatively limited amount of resources behind that. It is something where we really like to have these kind of trainings, and that you are not, or that our trainings especially, and then your testing is not limited by anything which you then have to pay a lot of money for. Yeah, again, you can use it, but if something happens, your data might be gone. Yeah, it's just, be careful. It's not supported. It's not something where we can guarantee long-term provenance of the data. But for these kind of things, to see if electrical lab notebooks is something for your lab, and I hope it is, yeah, because I really think that electrical lab notebooks is one of the central things to get our data problem solved. Test it out, and then we can still see what else you would do when you go to a production, a real solution for your lab. Okay.
Yeah, so basically that's it. What we wanted to show at the moment. Maybe Thomas, you can also give an outlook on the alternative for the Synode. If it's not the 7past9 Synode version that you just said, what this limitation has, what people would then be advised to do.
I'm not a Synode salesperson, even if it seems that I'm becoming one. But it's, I think we have to see, or you really have to think about that yourself, because I'm not or I did computer experiments a while ago, and my last being in a lab, I think, is I don't know, I don't want to count it even, the years. It has to fit into your normal process. Yeah, I think Synode is a good solution, but there are others. I think they are all much better than something written on a physical notebook. Yeah, but if you want to know more, if you want to get some advice on how to get an elect or a synode, because I also don't know much of all the others, but clearly everyone is I will answer whatever I can. Yeah, that's absolutely sure. But it's also clear it's a software. Yeah, we should probably go away from this idea that everything is for free, because there are people who spend time to develop this software. Yeah, therefore, you should also say, and I think it should be just become part of the budget. And I'm just one comment to data management in general. I now ask everyone to add at least 10% on top of each experiment they do, time-wise and probably money-wise, to do data management. Yeah, that everyone really thinks about that at the beginning, that there are some parts, and it will become cheaper as more. It's like normal experimental work as well. Everything you do is becoming faster, cheaper, the more often you do it. You know, therefore, there is an investment, yes, for sure, but I hope that these tools, which we still will provide for free, you know, like the instance maps, will help you, and then it's so much easier to connect. And this is exactly what you have here. Yeah, that you have these very easy links to data files where you can at the moment use everything just to start with, and then when you have started, then think about how to do that better. And at the beginning, it doesn't have to be sign-out. It can be an Excel sheet, it can be, as Ben showed, an Word document or whatever. You could even, when Martin was presenting this idea of using it to structure your your or to design your study, link in publications or link in the description of the experimental protocol from a publication, something. It should also be some kind of an external memory where you can just put in whatever you know about this one piece of your experiment, yeah, one part of the experiment you have.
Okay, thanks, Thomas, for that clarification. We do have a comment in the audience.
More questions.
Or my question, yes.
Question for all of you who have been working on these labs now. As Thomas mentioned, there's a lot of freedom now involved in building them. And does that, in your experience, make any issues that different people thinking about the same design, the same experiment, will probably end up with different instance maps? Is that an issue, or doesn't matter?
So the question was whether it creates an issue that different people are coming up maybe for similar experiments or experimental designs with different instance maps. Whether this makes life problematic for us.
I think at the moment it's the only thing we can progress, because we need to first figure out or have all these different point of views, to then identify if there is actually something in common. Yeah, I think it's quite hard to now sit down and say, okay, these are the rules, you have to exactly follow that, because that will result in frustration. I think this is what I see with all the data templates, and the similarities are very, very, very clear. Yeah, that when you limit people get frustrated because they cannot do what they want. At the end, I think the instance map will also have multiple purposes. And if you just said, like Ben started with, if you just want to discuss that with your your PI, or if you want to present your study in a paper or your PhD thesis, nobody cares if you. It should be representing your kind of thinking. Yeah, and then the rules. There shouldn't be rules at all. Yeah, because if it doesn't make sense to you, it will never make sense to somebody else. If you go to this data basing, yeah, or data managing type of that, then it will be a little bit problematic, or we will see how problematic that gets. But in the combination of the data files, which at the end become something different than what we just said, yeah, it will not be Excel or Word at the end. It needs to be something which is then generates the data in a fair, computer readable, harmonized, whatever, interoperable. Just put every kind of buzzword you remember on top of that. Yeah, this is the goal. But I think we have these two possibilities. Either we could streamline the instance maps and say you have to follow exactly these rules, or we could just create a system behind that, which is then collecting the data and then transforms it into something which is then more similar at the end, or where you see a little bit, or the differences will not be that dramatically when you really look at the data. Yeah, and the big thing, and we had an example in there where we already run through the whole data management thing, and the main complex part of this whole data management is actually to cover which sample you had in instance 1 is at the end ending up as sample in the measurement. Yeah, Martin or Ben showed these two different ways of synthesizing the, what it is, titanium dioxide, I think, nanoparticles. You have to cover that. Yeah, you have to say, okay, when you are then in instance 5, you still know which one of the samples is synthesized by method A and which is covered by method B. I would like to have them, as Ben showed, in the same instance map. Yeah, but we can then structure or create something behind that which covers all these. Yes, sample A becomes sample B, becomes sample C, and then it goes into the experiment, and then this is the result, which you can really trace to the original. I think this is more important to cover that very, very exactly than forcing people to have exactly the same instance map.
Okay, so reflection from Ben on the question from Dieter.
Yeah, I have a little comment out of experience of this, because we tried to make instance maps based on the same protocol with different persons. And I mean, the instance maps were basically the same. They had just some additional nodes in the different versions from the different people. But I feel like you can easily compare it to when people write their material and method section on the same protocol. They always word it a little bit different, but in the end, it says the same. So you can sit down at the end and try to simplify it, try to remove some nodes to make it easily understandable. But in the end, I would say that it's the same for everybody.
Good. So then we have also a comment from Tassos. The microphone is already there.
Thank you. I'm Tassos. I'm one of the first of the initial students on the internet. And I have seen how they evolved from what the Alicia and the group she works with, so the Christian, Mark, and same developed. So firstly, I'd like to make a small advertisement. So if you'd like to some more data maps, how they work, what they do, and etc. Please go to the tutorial that is put together, and there is also a publication on that. So that's the publication, because it's very good to see the background of thinking and so on. Then you should take the instance maps and the tools that Thomas team has developed as part of the data management process. And more, in my personal opinion, as a data management visualization process, which then support spends govern that. Eventually, they will come together because it's not a data capturing tool or a data repository tool. It's a way to visualize your work and see if it's a forgotten something or something that is not there or something is missing and so on. And with the work that Thomas is doing right now, to implement links to other data resources, then it becomes part of the data management process and data management lifecycle. In practice, linking the different tools, the data capture tools like the different notebooks, and then the data repositories where the data may be stored. But this tool, the maintenance maps, will help you to keep yourself on track, not to forget something, and to design your work better, as Martin has said. And the comment I would like to make on that is that I believe that before having a new student using this tool, the student needs to go through some basic data management skills and training on what data and metadata, the different types of metadata. So what the person is able to understand to a specific degree, what needs to be captured, what needs to be there, what needs to be followed, so as to create something of sufficient quality to be published. And in doing so, then different interaction with more experienced people, you will have a complete result and you will have a person, a scientist, and a professional that is fully educated on how to perform data management, design experiments, perform the experiments correctly.
Thanks a lot, Tassos, for this also very comprehensive and deep insight from somebody who has worked very long on this. And with this, I don't know how I started my sentence. With this, okay. So I guess we probably put on table what the tool can do. It was nicely summarized and even more comprehensively alluded to now finally by Tassos. Thomas, anything to be added at this stage? Otherwise, I would conclude for today. No.
If you want to give me a couple of seconds, I just can show two things. I have to quickly find them, but in principle I should be able. The one
share the screen. You share the screen?
I will then share the screen. Yeah, give me a second. Just because I couldn't unfortunately not hear everything what Tassos was saying, but I think he was mainly covering the importance of data management, and I think that is what I tried to also showed in the short presentation I had during the conference, and this is just a slide again. The important thing really what I wanted to say, when you think about this data management, the advantage of that is that you can start at the beginning, that you can already fill in whatever you have in these early parts and then continue to do that. And you can also choose the best tool to cover these information, yeah, like Synode for protocols, but perhaps when you then do more analysis, or if the data is already in some form, digital form, because it comes out of the experiment, then don't manipulate that, just use it, yeah, because you can then do whatever the software can do. Yeah, at the end there should be something other people can also read. Yeah, if it's something which is very specific to this one experiment or the instrument, then this is problematic. But in many cases these are open file formats. Therefore, at least add it to that. Yeah, because even if nobody can use it, then nobody can use it. But as soon as one person can make use out of this file, there is additional information in there. Yeah, this is the one thing. The other thing I just wanted to quickly mention is that we are really thinking to what we can do with that all. And one idea we also had is that this could actually be used also in a little bit the opposite way around. Yeah, what you saw with all the examples we had more or less one starting material, and then we followed the road of this material somehow to a final solution or result we are interested in. But because we have this idea of being able to to just visualize what we have, was also the idea that we put that into the regulatory area and think, can we, or in principle, have these requirements, yeah, that you say, okay, I visualize what is actually required for doing something or for starting something, and we could give you these kind of things and say, okay, if you, this is the minimal reporting standard, yeah, you have to report size and whatever, and before you didn't do that, in principle your results are not understandable or not even interpretable, because you not really know what the nanoparticle actually is. And this is just my first draft of requirements for REACH, yeah, mainly on the PhysChem properties. There are shapes, aspect ratios, this crystallinity, and so on. Many things in there. There must be much more, but in principle, you can then also say, and this is just another picture I quickly show. This is not from my side, but it's very small. Just 1 second, just to get that more. Again, this is not for me, but I think it's very important. That was a little bit big, too big. To see what the different regulations actually have as requirements. Yeah, and you can nicely present that in these kind of table. But in principle, I think you can also, or even better, present that as an instance map, because then you would see these two different maps side by side and say, oh, look, these are the same, the combining tools and or the combined properties we need. And here, there is something missing which you don't need when you are whatever. Veterinary medicine. Yeah, okay, perhaps that's not that important for us here, but anyway, I don't know. Yeah, but just to know that it's going a little bit in the direction of what Dieter was asking about, comparability of instance maps. I think that is one point we have to definitely think about. Yeah, can we take two instance map and then compare them in a way that we see, okay, here they're different. It would be very nice if we could do that here. That's all I had to say. I wanted to fill a little bit, but if you have questions, please let me know. I'm available the coming days. I'm always available by email. Therefore, I hope you have my email. Everyone has my email. If you want to have access to the tool, send me an email. This is unfortunately at the moment the only way to get access to the tool, but there is a reason, and good that I talk about that, because I wanted to also give this reason. What you saw is that you can share it, and sharing is by group. And we have one group, which is the training group, which is more or less everyone. Therefore, whenever you post something to that, more or less everyone on the tool can see it. We have separate individual groups, and if you want to have a group for your group, for your research group, then please also contact me, because then you could, for example, share with your PI or your postdoc or whatever, or your colleague beside you, and you can work on them, or at least you can see them together. When Katie was asking me how to edit something, I said, make a copy. Only one person can actually edit an instance map. If you want to edit the one from somebody else, you have to copy it. This is that you don't destroy anybody from anything else. We are working on solution of also having multi-user instance maps, but because we are still develop that tool, we said, okay, let's get it out as quickly as possible, because this will be really, really complicated. Yeah, because otherwise you will kill each other because somebody destroyed your instance map. There are ways to go back, but limited. Yeah, therefore, I don't want it to make bring there a lot of issues in by having people doing that in parallel on the same map, which will end in disaster. Now, therefore, one person can edit, you can copy when you have access to it, you can copy it and then create whatever you want out of this existing ones. I think that's really everything from my side. Thanks to the group who was there. And
also, thank you from my side, Thomas, for dialing in, for giving all this important insight. Thanks to Ben, thanks to Katie, thanks to Jalicia for running the show. And with this, I guess we are finished with this training session for today.
Thank you for your interest in our training on behalf of the NanoCommons project team and the European Union Nano Safety Cluster. Have a nice day.